Hi students, this is part 1 of your test number 7 review on exponential functions and exponents. Number 1, remember with exponential functions the form is y equals a times b to the power of x. Okay, remember what these mean. A, this is your y-intercept when you're talking about a graph. In a story problem, it's the starting amount. So for this one, 1/3 is our A. This is where our graph crosses the y-axis. If you look at the graphs, A crosses at 2, B crosses above 2, up here somewhere, whoops. C and D both cross well below 2, so those could be 1/3. Okay? If you look at these, kind of like where these numbers are. Okay, so let's eliminate A and B. The B is the growth or decay factor. Remember, if the number is greater than 1, it's growth. If it's less than 1, like a fraction, it's decay. RB is 1/2. That's less than 1. That's decay. So the way that a graph of decay looks like, here's your x and y, it's going to either, if it's above the x-axis, it'll start way up high and move close to the x-axis, or if it's below the x-axis, it'll start way low and move close to the x-axis. Decay is always approaching the x-axis. It's getting closer to it. So if you look at these two graphs, C gets close to the x-axis, whereas D moves away from the x-axis. So it's not D. The answer to number 1 is C. Since you have your calculator handy, you can also graph this in a new graph. 1/3 times 1/2 to the power of x. Remember to do the power of x, you do the little caret and then the x. Excuse me, let me try that again. The caret and then the x. And that'll get you up into the exponent. Number 2, let's look at this one. So in this one, the A is the 4. That's the y-intercept. Answer choice A intercepts at 2. That's not right. B also intercepts at 2. That's not right. C intercepts what looks more like, kind of like 3 to me. That's not right. D is the only one that intersects the y-axis at 4. D must be our answer. Just to verify, take a look at your B. Your B is 2. Because it's greater than 1, that's going to indicate growth, which means the way the graph is going to look, it's going to move away from the x-axis like it does on D. Remember, you can also type this into your calculator, into the graph. 4 times 2, then you'll do the caret x, and then graph that, and it should look just like answer choice D. Here's a few more. These are going from the graph to the equation. So if you look at both 3 and 4, they both are moving up and away from the x-axis. That means that the b value, the second number, should be bigger than 1. The b should be greater than 1. That indicates growth. Okay? So if you look at the b values for all of these, any ones that are less than 1 you want to get rid of, like A and C, like A and D. So the other ones I've underlined that I didn't cross out, those have a b greater than 1. In fact, they're all 2, which is fine. All right, the next thing we want to look at is where does it cross the y-axis? 3 crosses right here at 5. Looks like 5. So that the A is 5. That should be the first number. So for number 3, the answer is D. Let's look at number 4. It's crossing the y-axis at a number below 1, it looks like. I misread. Ooh, okay, let me fix this. I crossed off this answer choice and it's not correct. This 4 is my b. I looked at the 1/2. That's my a. In this case, my a, my y-intercept, does look like it's about 1/2, right? So that's this guy. The 4 is bigger than 1. That indicates growth. So A is going to be my answer here. Sorry about that. The A for B and C answer choices are 4 and 5, which are way too big. Those y-intercepts would be up here somewhere. All right, for the next few problems, we're simplifying and making sure that our answers contain only positive exponents. So let's look at number 5. It looks like I have all my powers are being multiplied together. So remember, if any of those powers have the same base, then we're going to add their exponent. So let's take a look at what we have. First of all, I see this x to the power of 0. Anything to the power of 0 equals 1. And 1 times all of this is just going to be all of this. So it basically is, we don't have to really worry about it anymore. Let's see what else we have. I see this coefficient of 3 and 2. I can just multiply normal numbers like normal. 3 times 2 is 6. And then my two powers, I've got x to the 4th and y to the 2nd. They don't have the same base, so I can't add their exponents. So I'm just going to rewrite those. And here's my answer, which is answer choice A. All right, for number 6, I've rewritten it. I've got the coefficient in front of 2, and it's the only coefficient, so I'm just going to rewrite that guy. All my other powers are being multiplied, so if they have the same base, I'm going to add their exponents. Let's look at my n's. This first n, I don't see an exponent, so it has an exponent of 1. So I've got this power with a base of n. I have another power with a base of n. I'm going to add those exponents of 1 and 3. 1 plus 3 is 4. Now I'm going to look at my powers with a base of m. Their exponents are 3 and 2, so I'm going to add the 3 and the 2 to get 5. Here is my answer, which is answer choice D. All right, let's take a look at number 7. Anytime you have parentheses with an exponent outside, like this 4, you're going to multiply it by every exponent inside the parentheses. If there's any base or number inside the parentheses without an exponent, make sure you put a 1 above it and multiply that 1 by that outside exponent. So it looks like I just have two bases, A and B. So I'm going to multiply both of their exponents by that 4. So for my base of A, I'm going to multiply -2 times 4, which is -8. For my base of B, I'm going to multiply -3 times 4, which is -12. So I've gotten rid of that outside exponent. Now I've got to deal with these negative exponents. Whenever you have a negative exponent, of course, remember with these problems, we need to express all our answers with positive exponents. So to get rid of a negative exponent, you're going to change the exponent to a positive, and then you're going to move the entire power down to the denominator. So that a to the -8 is going to be a to the +8, but it's going to be now in the denominator. We'll do the same thing with b to the -12, make the 12 positive, and move the whole power, b to the +12, in the denominator. If you don't have anything in the numerator, you can just fill it in with the 1. Here is your answer, answer choice D. For number 8, we're going to take that outside -1 and we're going to multiply that exponent by every exponent inside our parentheses. The 2, I don't see an exponent on, so it has an exponent of 1. The m has an exponent of -1. We're going to multiply both of these exponents by that outside -1. So for the 2, my base of 2, I'll get the exponent of 1 times -1, which is -1. For my base of m, my new exponent is -1 times -1, which is +1. Now let's clean this up a little bit. Remember, I want to get rid of any negative exponents. So this power has a negative exponent. I'm going to change that -1 to a +1, and I'm going to put it in the denominator like this, 2 to the +1. The m to the +1 was just fine because it has a positive exponent, so that guy's going to stay in the numerator. Now you can simplify this further. Notice anytime you have an exponent of 1, you don't really need to write it. So I can get rid of these 1 exponents and just write it as m over 2. And this is simplified, and that's answer choice A. All right, number 9. In 9 and 10, we're dividing. Remember, the fraction bar indicates division. So you can think of it as everything in the numerator is being divided by everything in the denominator. Always start with your coefficients. These are just normal numbers. You're going to simplify that fraction 4 over 2. It simplifies to 2 over 1, or just 2. Actually, let me get rid of that fraction bar. I might not need it. For any powers that are being divided that have the same base, like these two that have a base of m, you're going to subtract the top exponent minus the bottom. So for the base of m, I'm going to do 4 minus 2, 4 minus 2, which is 2. Now my n squared doesn't have another n to divide by or combine with, so we're just going to rewrite him. And here's our answer. Here's our simplified answer. This is answer choice D. All right, number 10. So the coefficient of 2, it's the only one. I'm just going to keep him. Let's look at our powers that have the same base. Let's check out these guys. U to the 0 power, which again, remember that is just 1. But let's pretend like we forgot about that. Let's leave the 0 there for a second. And then in the denominator, u to the negative 4. So for our base of u, and I'm going to write this off to the side, we're going to take that exponent of 0 minus that exponent of negative 4. 0 minus negative 4. So you can type it right into your calculator like that, and that will equal positive 4. Okay? Let's look at our v bases. We'll take the top exponent, which is negative 1, minus the bottom exponent, which is 4. Negative 1 minus 4 is negative 5. All right, so now we've put everything together. Now we just need to account for our negative exponent, which we have in this power right here. The 2 and the u to the 4th power are just fine. We don't need to do anything with that. But that negative 5, we need to change it to a positive 5 and move the whole power to the denominator like this. This is our answer, which is answer choice A. All right, number 11. Whenever I have a combination of multiplying powers like I have in the numerator and dividing, because I see that fraction bar, I always like to try to simplify the numerator and denominator separately, and then I can divide them by subtracting the exponents. Well, if I look at my numerator, the n squared and the m, they have different bases, so I can't combine those. So we're just going to go to the next step, which is dividing powers with the same base. I see n squared over n squared. So for my base of n, I'm going to take the top exponent of 2 minus the bottom exponent of 2, which is 0. N to the 0 power is really just 1, right? Also, you can think of anything over itself also equals 1. So all I really have left is just this m. My answer is just M, C. All right, in number 12, we've got a lot going on, so it's going to be really important to stay organized. I've got an exponent outside parentheses, that 2 on the outside. I also have the 2 inside outside of another set of parentheses. What I'm going to do here is I'm going to start there. I'm going to multiply by all the exponents inside the parentheses in the denominator. What I'm also going to do is simplify that numerator in the same step. But my whole thing is going to be like that. I'm going to deal with that outside 2 in a minute. I'm going to simplify my numerator and denominator first. Let's check out the numerator. So first of all, I've got a 2. I'm just going to rewrite that. My powers, the n has an exponent of 1, but there's no other power of n. So I'm just going to rewrite it. I can put the 1 there because I'll need that later. Let's take a look at my powers that both have a base of m. Remember, when you're multiplying powers like we're doing here, you're going to add the exponents. Negative 4 plus 3 is negative 1. Now let's take a look at the denominator. We're going to multiply that outside exponent of 2 by every exponent inside the parentheses. The 2 in the parentheses has an exponent of 1. The m in the parentheses has an exponent of 1. And the n has an exponent of -1. So we're going to multiply all 3 of those by that 2. So our base of 2 is going to have an exponent of 1 times 2, which is 2. Our base of m is going to have an exponent of 1 times 2, which is also 2. Our base of n is going to have an exponent of -1 times 2, which is -2. All right, I suggest still cleaning up this fraction before we deal with this outside exponent of 2. We're going to deal with him at the very end because I think we can clean this up a little bit more. I'm going to go wait over here. All right, so real quickly, I can see this 2 squared, I know is 2 times 2, which is 4. So I'm just going to replace it real quick with 4. And then I'm going to check out these coefficients. This is like 2 over 4, which simplifies to 1/2. Okay? Now let's look at the powers that are being divided that have the same bases. Let's start with the n's. I've got n to the first power in the top and n to the negative second power in the bottom. So I'm going to rewrite my n in my numerator, and then I'm going to subtract the top exponent of 1 minus that bottom exponent of -2. 1 minus -2. Type that in your calculator. 1 minus -2 is the same as 1 plus +2, which is 3. I'm going to do the same thing with my m's. I've got an exponent of -1 and 2. -1 minus 2, if I put that in the calculator, it gives me -3. Okay? Remember, all of this has an outside exponent of 2. All right, so what I'm going to do, everything inside is going to be multiplied by the outside exponent of 2. Let me just get rid of some things here. It's getting a little messy. Okay, so the coefficient of 1 has an exponent of 1. We're going to multiply that by 2. The n, we're going to multiply that 3 by 2. For the m, we're going to multiply that -3 by 2. In the denominator, we have an exponent of 1 on that 2. We're also going to multiply that by the 2. So we've got a lot of things to multiply here. So in the numerator, for my base of 1, I'm going to have a new exponent of 1 times 2, which is 2. For my n's, I'm going to have a new exponent of 3 times 2, which is 6. For my base of m, I'm going to have a new exponent of -3 times 2, which is -6. And then in my denominator, for my base of 2, I'm going to have a new exponent of 1 times 2, which is 2. Now I've got some cleaning up to do here. A couple things I see. I see these, anytime you have a power with a number base, you can simplify it. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. So I just simplified both of those. The n to the 6th power is just fine. The m to the -6th power, though, I don't want to have a negative exponent. So I need to change that to a +6 and move the whole power down to the denominator. The only other thing I can do here is because I have that coefficient of 1, I need to remember that I don't really need to write it. So here is my final answer. N to the power of 6 over 4 times m to the power of 6. All right, now we've got a couple word problems. A lot of times in these word problems, yes, there are a lot of words. Look for the important parts. What I would focus on here is the table for sure. I would maybe focus on this equation for sure and what the variables represent. X is the number of years since 1900. That's this part of my table. Y is the amount of oysters harvested in metric tons. That's this bottom part of my table. Notice, I don't really need to know what these mean. I just need to know where the numbers are, okay, and what the parts of the equation represent. The question says, what does the Y-intercept represent? The Y-intercept is your A. Remember, Y equals A times B to the power of X. This is your Y-intercept, okay? This is where your graph has an X value of 0. This is where your graph crosses the Y-axis. This is the starting amount, okay? So let's see which answer choice makes sense. In this case, our A is 51.7, okay? And the Y-intercept means it's going to have Y units. So that's number of oysters in metric tons. So let's see which answer choice makes sense. A, the rate at which the oyster harvested declined each year. That would be the B value. The B is a rate. That would be this number. So it's not A. B, the number of years since 1900. That's the X value. That's not the Y-intercept. C, the amount of oysters harvested in year 0. That's key. It's the starting amount, okay? It's when X is 0. Well, X is years, right? In year 0. D says the amount of oysters harvested in 1900. That would also be correct because in 1900, these are years since 1900, so when my years are 0, that is 1900. So I would accept both C and D. Let me check with the answer key and I'll see if one is better than the other. But to me, they both look good. All right, another word problem. Pay attention to your table. Pay attention to your equation and what the variables represent. X is the number of years. Y is the value in dollars. Okay, what does the Y-intercept mean? So again, we're looking for the A. What does it mean? Our A is 5790. And remember, the Y-intercept, it's going to have Y units. So this is the value. So this is a dollar amount, right? Remember, the A is where you start from. It's at the beginning. It's when X is 0, or in this case, year 0. So it's the money when year is 0. Let's see which answer choice makes more sense. A, the number of years until the investment triples. No. Number of years would be an X value. We're looking for a Y value. B, the average annual interest rate. No, that would be our B. Anytime it says rate, that's referring to the B. C, the average amount by which the investment increases each year. That also refers to how it's growing, not the original amount. D says the original amount. Perfect. That's exactly what it is. All right, here's another word problem. You want to pay attention to your table. You want to pay attention to your equation and what the variables represent. X is the corruption score. I don't really need to know what corruption score means. I just need to know that X represents it. Y is the GDP per capita in dollars. I don't really need to know what that equals. I just need to know that Y represents it. Okay? According to the model, what would be the GDP per capita? So that's your Y. What would be your Y or your output? With a corruption score of 37. Corruption score is your X. So when X is 37, what's your Y? That's basically what it's asking. We're going to use the equation. All we have to do is replace the X part of our equation with this 37. So it'll look like this. 1780 times 1.04 to the 37th power. All you have to do is type this into your calculator and press equals. And when you do that, you get answer choice D, $7,597 about to the nearest dollar. Real easy. You just plug it in. Boom, there's your answer. Another word problem. You got the table. You got your equation. X is the number of years. Y is the value in dollars. According to the model, what is the value in dollars? That's your Y. So what's your Y? What's your output of the investment after 5 years? years is my x. So when x is 5, what's my y? Go right to the equation. You're going to replace the x part with 5, just like we did before. So it'll be 5,700 times 1.08 to the power of 5. You're going to type this into your calculator, enter. It gives you about $8,375 rounded to the nearest dollar. Pretty easy, just plug it in. Here's a similar problem. Here's your table, here's your equation. X is the number of years. Y is the population. What will the population be? Population is Y, so what's your output? When it's 34 years old, years is X. So when X is 34, what's my Y? Plug it in. 796,000 times 1.02 to the power of 34. When you type that into your calculator, it said round to the nearest 100, you get about 1,560,700. All right, last problem, real similar. You've got your equation. X is the number of years since 1900. So 1900 would be like X is 0, okay? 1901, X is 1, and so forth. Y is the amount of oysters. According to the model, how many metric tons, so what's your Y, what's your output, were harvested in 1866? So we're going to have to figure out, we know the years are X, but what X value is that? 1900 is X is 0. And all of these numbers are years since 1900 or after 1900. Well, 1866 is before 1900. So we have to see how much before is it. If we subtract 1866 from 1900, we get 34 years before 1900. That means our X is actually a negative value. It's before this amount. Okay? So negative 34 is what we want to plug in for X. So we're going to rewrite our equation. Y equals 48.4 times 0.968 to the power of negative 34. And you're going to type this into your calculator. So it's going to predict what happened before 1900. And when you type that in to the nearest tenth, it's about 146.2 metric tons. Okay, if there's any problems I just went over that you're still struggling with, jot them down and make sure to ask me in class or tutorials. See you soon. Happy studying.